¿Quieres estar a la última en innovación? Visita www.centrodeinnovacionbbva.com.
Well, CartoDB is also a great friend from BBVA and also from our open innovation projects. In fact, during our Innova Challenge MX, the last competition we launched during November and December, we did a good number of activities in a roadshow in Mexico, different cities in Mexico. I think there were like 5 or 6, I don't remember. I only remember a lot of tacos. And then we also went to New York and San Francisco and Austin. And everywhere we found these really great examples about the interesting uses of CartoDB. You also have lots of good examples in the exhibition because I think we have like 5 projects or so. And also, of course, by going to CartoDB.com, you can know more about the technology. But we have here one of the top experts of the tool, Paul Ramsey, Solutions Architect at CartoDB. And, well, he has been working with geospatial software for over a decade, consulting to government and industry, building geospatial software company, and programming on open source. So it has all the interesting things: open source, geospatial, CartoDB, lots of data, and interesting technology. Please welcome Paul Ramsey.
Thanks. So yeah, I'm from CartoDB. I'm from Canada, the West Coast, but CartoDB is from right here in Madrid, a super company. You're all here to talk about big data. That's a big challenge, trying to provide analysis and context for the data that BBVA is making available for this innovation challenge, for your own big collections of data. So you got to analyze and find useful patterns in a sea of data, and you've got to visualize that data in a useful, actionable way for end users. And I've got no doubt you'll find plenty of opportunity to trot out old standbys of business information, bar charts, the scatter charts, the pies, and the web. But I hope as you analyze your data, you also look carefully at the geographical context inside it, because when you bring geography into your analysis, you have the potential to unlock extra insights that would otherwise be unavailable. And of course, you can build some very pretty pictures that tell you something surprising about the world. When I visited New York, I never really thought about the topography. Like the landscape's dominated by buildings, the human environment, the built environment. They're way taller than any of the hills. And yet, there is a noticeable topography. You climb and descend hills as you walk through Manhattan and Brooklyn. Usually, when you put contour lines on a map, you put them in a very subtle gray. But this map maker chose to highlight them and make a really bold message with a bold palette to really drive home the message. Hey, New York really does have hills. This is a more conventional map. It's what cartographers call a chloropleth. It's an election map for the last mayoral election in Toronto, in Canada. It was a 3-way race, and the cartographer chose to color each polling area based on the candidate who had most votes. And then within that color, she used deeper colors to indicate the stronger support for that candidate. And the result is a map that shows 2 variables at the same time: the winning candidate and the strength of support, in a very visually concise form. This one's a chloropleth too, and I really like this one because it's a great example of variables showing off secondary characteristics. So the cartographer here got a hold of the parcel data for New York, but instead of doing a conventional thing and mapping assessed value or date of construction, he threw together a simple little map that colored up the parcels by their street number. So you can kind of see the low numbers in the general wash down in the south in the old city, and then the sweep of planned numbering up the street grid that was laid down during the years of explosive growth in the mid-1900s, but with a spine along the middle of Broadway, which is numbered continuously from the south to the north. So you can kind of see a little history lesson, a little urban planning lesson just from mapping out the street numbers. This is also a chloropleth, but less conventional. Each river in the continental USA is given a color based on direction of flow. So you've got north, east, south, and west. And the result is a map which, yeah, it shows the stream locations, but it also highlights the ways the basins divide. You can see the tributaries entering the major rivers clearly and the divides between the major basins. And all that with just one simple coloring rule. So combining old data and new, this is a great cartographic trick. It's all about contextualization, right? These are just dots on a map. But if you contextualize the dots with a background map, old US battlefields all of a sudden look old when you put them against an old base map. It makes the case and it makes a great presentation piece. The base map says, hey, look, history. So sometimes you don't need a lot of color to tell a story. But you got to watch out that you don't tell an inaccurate story. So this is a really famous map of red America and blue America. It's the presidential election results, in this case, county by county. And as you can see, there's a lot more red America than there is blue America. Except what there is actually is a lot more red land than blue land in America. And land doesn't vote. People vote. This map shows just how skewed the land to people ratio is. It's quite easy to create misperceptions using cartography. Half of the United States population lives in the red counties. It's very small areas. It's easy to create misperceptions with cartography. In fact, it's so easy that if you go to university and take courses on geography, it's not uncommon to be assigned this introductory book, How to Lie with Maps. It should really be entitled How Not to Lie with Maps, because lying with maps is so easy. So I've showed some static visualizations, but a lot of location data these days it comes with a really strong time component. It's spatio-temporal data. Each record comes with both a location and a time. So GPS points, ATM transactions, payment transactions, most modern digital photos, tweets on Twitter, almost any record generated by a recent smartphone. These are all spatial-temporal data. They combine a location and a time. And CartoDB lets you visualize spatial-temporal data by rolling them up into an animation. Now, usually it's a relevant slice of the data, an hour or a day or a week, depending on the scale. And this is bus movements in Los Angeles. It's a little truncated, so I could fit it into the slide deck. This is a visualization of a Twitter search. It's possible to build a CartoDB query directly against the Twitter feed. So you can create these spatial-temporal visualizations of Twitter terms. You might have seen one during the World Cup. During the Germany-Argentina match. This is a similar singular event in time. It's the surprise online release of Beyoncé's latest album, which was a much bigger deal, you can see, in the USA than elsewhere. When the spatial and the temporal combine, oops, yeah, there we go, things get really fun. So in this case, someone had the bright idea to build a Twitter search around the term sunrise and did it in a number of languages and watch it run over the course of a day. So you go, woo, it's sunrise, hey. So aggregate visualizations like these are really interesting, but some of my favorite involve just a few discrete moving points. So back in 1962, 3 men imprisoned on Alcatraz in San Francisco Bay hatched an escape plan. And over the course of the year, they scraped holes in the backs of their cells with spoons. And then on June 11th, 1962, they crept from their cells, they climbed over the outer wall, and they left the island on a raft that they fabricated with prison raincoats and contact cement. They were never seen again. The FBI concluded they drowned in the attempt. Last year, a research team from the University of Delft in the Netherlands reconstructed the tidal actions on the night of the escape. Now, there's some difficulty in paddling a raincoat-built raft, right? You can't paddle it very fast. So their path would have mostly been determined by the tides in the San Francisco Bay. And the Delft team modeled the paths of boats entering the bay at different times of the night. On this animation, each entry hour is given a different color. Only the green entry, it's the one just crossing under the Golden Gate Bridge now, only the green entry, where they got into the water right at midnight, avoids either being swept out into the ocean or back into the bay. Only the green guys actually have a chance of being able to paddle to shore. So really, the only chance they had was if they entered the water exactly at midnight. Probably they didn't make it. So, yeah. So maps are very powerful tools for visualization. You can put a lot of information on a map, and people will come away with a strong understanding of what you're saying. But visualization isn't where map making stops. It's just the first step, which leads to inference and analysis is hopefully more visualization on top of the analysis. So one of the fathers of geospatial analysis is a London doctor named John Snow. Actually, not that John Snow. That's a hero of Westeros. This John Snow, he was a physician in London in the 1850s, and he had a problem. People in the Soho neighborhood of London were dying of cholera, and nobody could figure out how to stop it. And a big part of the reason they couldn't stop it was because they didn't understand how it spread. The dominant theory of disease at that point was that diseases were transmitted by bad air, by smells. Fortunately, Snow didn't just rely on theory. He empirically studied the data. He started with a map of the neighborhood, and then for every recorded cholera death in a building, he filled in a little black rectangle in front of the address on his map. And the results looked like this. So there were a lot of cholera deaths in Soho. But backed out and looked at the neighborhood within the context, the larger context, everything became kind of clear, because what stands out is the centrality of the Broad Street pump to the epidemic. Maybe there was something in the water coming from that pump, which is right in the middle of all the cases, that was causing the epidemic. And yeah, cholera is waterborne. That was exactly the problem. Snow showed his map to the local authorities, and they weren't so enthusiastic about it, but presented with the visual evidence, they agreed to remove the handle from the Broad Street pump, and the epidemic subsided. So I'd like to recreate for you John Snow's cholera map using CartoDB for a quick demonstration of how easy it is to build data on a map and share it using modern tools. So, live demo. Okay, so start off with the CartoDB dashboard. There's two kinds of objects we manage on the dashboard, maps and data sets. So these are the maps, but I'm going to go get some data sets for the cholera problem. So first I'm going to load the mortality data for the Soho cholera outbreak. Let's see, so there's the deaths. I'm going to copy a public link and make a new data set. So data sets you can load up. You can load things from Google Drive or Dropbox directly. You can load all sorts of formats, CSVs, Excel files, JSON files. I'm loading a GIS format called a shapefile. You can load them directly by selecting files on your local computer, or you can give the system a URL where the data resides in the network. So I'm doing the URL option here. Oops, no, I'm not. I'm clicking the wrong button. What am I doing wrong? I can't see. Oh, submit. There we go. Now, when I do a URL, it gives me the option of syncing it. So if I had live data and put it on the net on a regular basis, the system can slurp up the new data on a schedule, so you can keep your map live to the current data if you want to. So I don't need to sync this because it's 100 years old and not changing. So that's one. That's the deaths, and I also want to add the pumps, so I'll copy that. Oops. Oh, so here's my cholera deaths. I can't read my screen, but you can for each point, how many people died, and then an ID number. I want to go back and add the pumps. So I'm going to add a new data set. Yeah. Oh, is there advertising to me? My company's advertising to me. Submit, connect. So that gives me my pumps. And once I get my pumps in, I can put them together and make a map of them together. Oops. I'm going to make a two-layer map here. So I grab my pumps and my deaths, and I create a map. So it's taking two layers, putting them together. So I got a bunch of dots, but remember, John Snow didn't just put in a dot for every address. He put in a dot for every death. And as we saw, the cholera data has a column in there for each death. So it'd be better if I visualized each of those eyes that made sense. I go to my wizard, and I'm going to pick an appropriate style, which in this case is a bubble. So I'm going to get a bigger dot. For addresses that have more deaths. This is a very cheerful map, which seems inappropriate. So we'll do that instead. And we'll take its opacity down a little bit. And I've got part of the story, but I need to add the other part of the story, which is the pumps. And right now the pumps are kind of small. I'm going to make them red and make them a little bigger. And now we've got the story of Jon Snow kind of right there. Except it's not a map until you've said what it is. You need to title it, oops, and spell things properly. Soho. This is 1859. Oop, I should look over there. And let's get rid of this guy. There's one other thing I want to do, which is annotate it so that when folks look at it, they know what's going on. Tell them where the Broad Street pump is. Once you're done building up your map, that's all fine for you. You've now got an idea, but the important thing is to share it with people. So there's 3 options for sharing. A simple link, email it to your friends. Some embed HTML so you can copy it into your blog or your web page. And the CartoDB.js link, which is used to embed your map in a live app. And I'll show some of that later on. But you can copy this link. Boop. This is what people on the web would see. Hello, network. Yeah, well, IJMUBET. If you type that into your smartphone, you can see the link instead on your network that runs. Okay. So that's the demo. Boop. So the analysis in Snow's map, it's all visual, right? You squint at the map, and your brain sees the correspondence that you translate into meaning. It doesn't take mathematics or statistics to do it, which is why maps can be so popular with decision makers. But CartoDB isn't just a map-making tool, though it's very good at that. CartoDB is a spatial analysis and application building platform. So the map editor that I showed you is just an example of a very complex application running on top of the platform. And the platform has 3 important parts. It's got a database engine where the data is stored or analytical queries can be run. It's got a rendering engine where spatial data can be turned into cartographic output. And it's got a web map framework to provide the web-based interactions and the map cartography. And this would all be very interesting, but not that useful, except that there are languages that you can use to directly interact with each level of the platform. You can alter the behavior of the data and the queries that are going on your map using SQL. You can alter the behavior of the renderer, so change the look of the map using a CartoCSS cartography language. And you can alter the behavior of the interfaces that you build, the applications you build around the API using JavaScript. But in fact, you don't need to even start programming to use SQL and CartoCSS to manipulate your maps. They're exposed right in the editor. So I only showed you the cartography wizard in the editor, but in fact, there's multiple tabs in the editor that do all kinds of cool stuff. So one of them lets you change the SQL that's generating the data. So the default SQL, just show me all the data. But you can change the SQL to anything you want. You can filter out particular rows. You can recalculate column values. You can even join against other tables. Another tab in the editor lets you directly edit the CartoCSS that's driving the rendering of the layer. So the cartography wizard just generates appropriate CartoCSS, but you can always flip into the raw tab and tweak it by hand to get particular effects or colors that aren't via the wizard. And when you have full control of your data with SQL and CartoCSS, and you build your interface with JavaScript, you can build pretty much any application. In fact, as I mentioned before, the editor is just an example of a big complex application using the platform APIs. So the APIs in the platform are CartoDB.js. That gives you a client layer to work with in your web browser. Gives you access to layer definitions and lets you alter the SQL on the fly. The import API, which allows you to automate data loading and data syncing. So you don't need to click around your import. You can have it automatically slurp things up in your app. The Maps API, which lets you automate the creation of new layers and maps so you don't have to click around by hand like I did. And finally, the SQL API, which lets you run any SQL query against the data in your account. So to demonstrate the SQL API and analysis with CartoDB, I'd like to do another example of visualization and analysis for you, but this time a more modern one from New York City. So a couple years ago, the New York Times gathered up police reports for almost 8 years worth of homicides from 2003 to 2011. And in those 8 years, nearly 4,000 homicides were committed in the city of New York. And you can do straight non-cartographic things with this data. You can analyze it in the database using SQL, do things like look for seasonal effects. So this one is a query that gives you the frequency of homicides by month. So you can see the frequency of homicides goes up during the hot summer months. Although look at what I did just there. Huh? You can do this too. Don't need maps to lie. By truncating the scale, I made the seasonal effect look bigger than it is. Here's the actual unscaled chart. So you can lie with anything. So watch out, these smart people with their maps and their charts. Okay, so an obvious thing to do is put it on the map. Let's see, I'm going to go away from my cholera map. And I'm back at Mapland, and I've already got the homicides here. So this is 4,000 homicides. You can do some fun stuff with it. It is spatial temporal because they know the date of every homicide. So if you, there we go, animate them by their incident, that's the incident date, that's them happening in time as the years go by. It's kind of mesmerizing to watch, but it's not really that informative. It's not really that informative. No, it's not informative at all. So let's go back to something a little more basic. So we'll go back to a simple visualization. And we'll just we'll get rid of our stroke, and we'll make them a little smaller. That's better. And then we'll do the alpha blend a little more, take the alpha down a bit. So you can kind of see them overlapping the thicker areas and so on. So you can kind of see neighborhood patterns. It's better than the flashing lights. So do any other patterns jump out? This is where knowing your New York geography is helpful. But I'm going to add another layer here, and this will probably help. I've got NYC, there we go, Census Blocks. This is from the 2010 US Census. At the census block level, there's about 30,000 of these in the 5 counties, or 5 boroughs. For every census block, the census collects how many houses, how many people, and they actually collect the racial breakdowns by census block. So let's see if I'm allowed to look here. I want to see the data view. Is that? Yeah, so these are the census blocks. So what we got going on is for every block, population by race, and then a total population. So I want to make a chloropleth map. I could do a chloropleth map of just straight a population race, but that'll be washed out. Big blocks will come up more colorful than small blocks. I need a percentage. I need a ratio. I don't have a ratio in my table. So how do I get one? I can go back to my map view here and grab my SQL. Is that readable? It's okay. So I want to get, there's a few things I need. I need some things to map with, but then I also need the data, which is, I think it was population. Yeah, there we go. I'm going to get the population black divided by the total population. And I'm going to name it percentage black. So a little calculation on the fly. I'm going to get rid of one mathematical problem there. Remove my divide by zero errors. preemptively. And oops, no. And I go back to my wizard. Now that I've got the data I want, I'm in pretty good shape. Back this up to build a chloropleth. Or at least I would be if I changed my SQL. Oh, I didn't apply it. Always helps to apply it. Okay. Now we're better. Oh, there's something going on. What's wrong with this? There is a stroke, which makes it impossible to see the colors. Ah. Now we'll just take this to something a little more blue, perhaps. And so what do we think of that? Are we seeing any pattern yet? I think it helps if I put the homicides on top. Okay, so it looks like homicides tend to occur more frequently in black neighborhoods, or alternately that white people repel homicides. So we think there's a pattern. We're seeing it, we're eyeballing it. It's pretty compelling from a visual point of view, but can we go beyond our eyeballs? Sure, we can do a little bit of SQL, and this is the kind of thing you can do from a web form via the SQL API. I'm just going to show you the SQL though, because that's just the kind of guy I am. So that's what the SQL looks like for an all New York summary. So it's taking every single census block in New York, summing them all up, and reading out the percentages. So New York in total is about 25% black, about 44% white. There is an American geographer, he's named Waldo Tobler, and he described what he called the first law of geography, which is that everything is related to everything else, but near things are more related to each other than far away things, which is a nice friendly way of saying things tend to be spatially autocorrelated. So what if we use Tobler's law, and for every homicide we look at the census block underneath it and look at the racial makeup of that block? In aggregate, those blocks, the ones underneath homicides, would tell us something about the makeup of the neighborhoods where homicides are occurring. And you might think that might take a fair amount of math or a fair amount of code, but in fact with spatial SQL it's just a two-line join clause added to the original query. So we're getting the data from the census blocks, but we're joining it to the homicides. Every time a block contains a homicide, we get a record. Summarize those ones, and you can see the extent of the problem. So basically, the land, things are reversed. Homicide land is 48% black and 22% white. So mathematically, there's definitely a racial component to the odds of a homicide happening in your neighborhood. Spatial relationship contains, in this case, but you can do other ones, intersects, distance. It's a really powerful tool for bringing disparate data together. The homicide data and the census data, they were not collected by the same people. They were not collected using the same model, the same methodology. They weren't even collected in the same years. But by using their location and Tobler's law, we can draw them together into a simultaneous analysis. But numbers aren't nearly as convincing as something interactive, something that lets decision makers draw their own conclusions. So using the CartoDB platform and the CartoDB SQL API and the JavaScript API, I built a small web application to explore this problem interactively. So this is a very tiny one. There it is, called the Homicide Explorer. I didn't color anything up. I just gave you the dots. Actually, no, this is the same visualization. So actually, the dots are probably going to change as soon as I do this. Whoop. So look at every block with more than 11% white population. There's all the ones. What if I take it up to 44? This is the average white population. So homicide land in white neighborhoods, not so bad. Only 577. Over the whole of New York, 3,562. So this is basically just that same SQL query that I showed you on the screenshot. And I inflicted on you. And I'm sorry, it's ugly because I'm a terrible JavaScript developer. But at the top, I bring in the CartoDB JS library. Because I want a slider widget, I bring in jQuery UI. The SQL is just the same SQL I showed you before on the slide. It's a spatial join between homicides and census blocks with variants, one variant to put on the map and one variant to do a summary. The CartoDB JS library lets you declare your map in a single line. I'm just telling it, bind the map to this DOM object, the map DOM object, and use this visualization to draw onto it. And then finally, the interactivity of the slider is just a couple actions on the slider change event. Every time there's a change, update the map layer with the new number, and update the summary with the new number. That's it. So you can see the full code of that at blocks.org/PRamsey. And you can see lots and lots of a lot more attractive examples of map applications at the CartoDB gallery page. It's right there. So the world's now full of lots of spatial temporal data, and there's lots to bring meaning and interpretation to that data using maps, like John Snow did to make numbers easily comprehensible for decision makers, and doing spatial analysis like Waldo Tobler did, using the first law of geography and integrating data using spatial joining. So I hope you all try doing that sometime with CartoDB, the next generation mapping platform. Thanks a lot for your time. I'm happy to have any of your questions.
Si quieres estar a la última en innovación y emprendimiento, visita www.centrodeinnovacionbbva.com.